This video, we're going to discuss some separable differential equations. Now, these are equations sometimes like what you've already been dealing with in Calculus 1 and 2. Let me show you an example of that. If I say dy dx is equal to sine of 5x, you know that you can split this to say dy is equal to sine of 5x dx and then integrate both sides. Change my color here to say that I need a 5 dx for my du and a 1/5 to balance that out. So I have y of x is equal to 1/5 negative cosine of 5x plus constant of integration c there. So if it's already split for you, it could look something like dx plus e to the 3x dy equals 0. You need to make this dx equals negative e to the 3x dy. Separate the x parts from the y parts, and we get a negative e to the negative 3x dx is equal to dy. We'll integrate both sides here. We'll get y of x is equal to a, change my color here, I need a negative 3 and a negative 1/3, and that negative negative makes a positive 1/3, e to the negative 3x plus c. So we're going to try to solve for y when we can. That sometimes we're going to have differential equations where we're going to solve for x as a function of y instead. Let's go ahead and see if any of those pop up here. Let's look at this next one. This is still y as a function of x, but we're going to not have a plus c, we'll have times c, and I'll show you that here. So we're going to have 1/4y dy is going to be equal to 1/x dx. So this is the same as 1/4 times 1/y dy is equal to 1/x dx. Let's go ahead and put this over here. It really doesn't matter where that constant is. I'll put it there for right now. Let's integrate both sides. I'm going to have ln of the absolute value of y is equal to 4 ln of the absolute value of x. And normally we would say plus c to get our generic constant of integration, but because everything has ln's here, I'm going to say plus ln of c, and that also gives me a generic constant of integration so that I can use my ln properties here. So ln of absolute value of y is equal to ln of x to the 4th plus ln of c, so that c can come in here. And then by my 1-to-1 property, I can say y of x is equal to c x to the 4th. That's a very common technique that we're going to use in differential equations to add ln of c instead of just generic old c, and to get that as a constant multiplier there in our equation to drop this ln out here to solve for the function by itself. Let me look for maybe one more example here with some trig in it. We'll have cosecant y dx plus secant squared x dy is equal to 0. So let's separate this. Cosecant y dx is equal to a negative secant squared x dy. Bringing these secant squareds over, this becomes cosine squared x dx. Bringing this cosecant over, this becomes, there's a negative sign over there, negative sign y dy. And before I go ahead and integrate, I'm going to use my power reducing formula here on the left hand side, because I know I need to do that to integrate cosine squared. So this can be 1 plus cosine of 2x over 2 dx is equal to a negative sine y dy. This is 1/2 plus 1/2 cosine 2x dx is equal to a negative sine y dy. And so this is going to be 1/2 x plus, to need 2, another 1/2 here. I'm going to be integrating everything here. That. And so that's going to be 1/4 sine 2x is equal to a cosine y plus constant of integration c, something like that. Let's go ahead and call this C1. If I want to get rid of these fractions, then I can multiply everything by 4 and get 2x plus sine of 2x is equal to 4 cosine of y plus 4c1 is a generic constant like that. All right, that's it. Really doesn't matter which side the generic constant is on, and just matters. Usually we write it on the right-hand side, but all right. That'll suffice for right now. Again, watch out for things where you might be solving for x as a function of y. They do pop up every once in a while in this book, so watch out for those. See you for the next video.